Hello friends, this is Subhash Jadhav. Let me welcome you all in the lecture series for Assistant Motor Vehicle Inspector Examination. Here we discuss probable objective type multiple choice questions. Today we are going to discuss about fuel systems in CI engines. So let us start. And the first question is, generally a diesel engine as compared to petrol engine, the options are more efficient, less efficient, equally efficient, and none of the above. So we know that diesel engines are using higher compression ratios compared to petrol engine, and when the compression ratio is increased, the efficiency is going to increase. So the correct answer is going to be the more efficient, because generally we use higher compression ratio in diesel engines. But if you are going to compare on the basis of same compression ratios, then obviously the petrol engines are going to be higher efficient. But in generally, when we are speaking, we will be saying that diesel engines are more efficient because they employ higher compression ratios. So the correct answer is A, more efficient. Second question is, which of the following medium is compressed during the compression stroke in a diesel engine cylinder? And the options are air alone, air fuel mixture, air and lubricating oil, fuel alone. So here we are talking about what is being compressed in the CI engines, diesel engines. So we know that in a CI engine, generally during suction stroke, air is being taken. At the end of the compression stroke, fuel is being injected. That means initially there is only air. So what will be compressed? Only air. So the correct answer will be air alone, that is A. Next is, in a diesel engine, the fuel is ignited by. So we are talking about here ignition, and the options are spark, injected fuel, heat resulting from the compressed air that is supplied for combustion, and ignition system. So in a diesel engine, we know that what we do, initially we compress the air. The amount of compression is to a level where the air gets heated to such an extent that when we inject the fuel, that is going to burn. So the correct answer here is not the spark. It is spark is not used. Ignition system is therefore not there, and injected fuel. Fuel is injected by injected fuel, it is not possible, and therefore the correct answer is C, heat resulting from compressing air that is applied for combustion. Next, mixture in the combustion chamber of a compressed ignition engine is. Here we are talking of what is the type of mixture, and the options are homogeneous, heterogeneous, both A and B, and laminar. We know that in a diesel engine or a compression ignition engine, what we do, we compress the air initially, and at the end of the compression stroke, we are going to spray the fuel in the form of droplets into the combustion chamber. What is the mixture, what is going to form inside the combustion chamber will not be homogeneous, because there is no uniformity in the composition of the mixture inside the combustion chamber. Wherever the droplet is there, there will be only fuel, and wherever the air is there, there is only air. So if you take some sample from the region where only air is there, it will be only air. And from where a droplet is there, if you take some sample, then that will be only fuel. The amount of air or amount of fuel, there is no homogeneity in the nature of the mixture, and therefore correct answer is B, heterogeneous. Next is, the dash engine can work on very lean mixture of fuel. So here the options are spark ignition, compression ignition, both A and B, and none of the above. Obviously we know when we ignite a mixture in a compression ignition engine, what we do, we spray the fuel in the form of droplets. And how they are getting ignited? They are getting ignited due to the heat received from the hot air. Even if it is a lean or rich mixture, if there is sufficient amount of heat and sufficient amount of oxygen around the droplet, then that possibility of that droplet being getting burned is higher. So here we are talking of which is that engine which can be burnt with a in case of a lean mixture. Obviously, in compression ignition engine, the change in the amount of droplets is not going to affect much. On the contrary, when we have a petrol engine or a SI engine, we have to supply the fuel in the inflammability limit. If it is higher, that is higher than that or lesser than that, we are not able to burn it. And therefore, the correct answer is, which is the engine which can burn lean mixture? It is CI engines. So the option is B, compression ignition engines. Next is, diesel engine can work on very lean air fuel ratio of the order of 30. A petrol engine can also work on such a lean ratio provided. So here we are talking of a probability where the diesel engine is able to work at a ratio of 30:1, but if what is the probability of such a mixture, that is 30:1 mixture of burning inside a SI engine? And the options are: it is properly designed. If it is properly designed, best quality of fuel is used. Cannot work as it is impossible. Flywheel size is proper. Obviously, here we can see below air fuel ratio is greater than 19:1 or below 9:1, it cannot burn. Here it is too rich, here it is too lean. That means if it is 30:1, obviously it is above 19. That means it is too lean, and we know that if it is too lean, then it cannot burn. So the correct answer is C. It cannot burn as it is impossible, because we cannot sustain the flame which is supposed to be travel inside the combustion chamber when the mixture is too lean. Next, the self-ignition temperature of diesel is dash compared to petrol engine. So here we are talking of self-ignition temperature of the fuel. So options are same, lower, higher, none of the above. So we know that why we prefer to use the compression ignition method in case of CI engines. The reason is that the fuel itself is having lesser self-ignition temperature. If the fuel was having a higher self-ignition temperature, then the requirement of the compression ratio will be even more, which will make the engine more bulky, and it will not be a feasible solution. And therefore the correct answer is here lower, and preferably when we are talking of lower, we are here speaking when compared to that of a SI engine. So when compared to that of a SI engine, the CI engine fuels are having lower self-ignition temperature. The self-ignition temperature of diesel is about, here the different values are given, and the correct answer is A, that is 210 is the self-ignition temperature of diesel engines. So depending on the composition, it ranges from 210 to some value around 230, but it will be lesser than petrol. In diesel engine, the compression ratio in comparison to expansion ratio is, so here we have a diesel cycle. Here 1, 2 is your, that is compression, and 3, 4 is your expansion. So you can see over here the compression ratio is V1 upon V2, and the expansion ratio is V4 upon V3. Obviously V4 upon V3 is smaller than V1 upon V2. So in a diesel engine, the compression ratio, this compression ratio is what with respect to expansion ratio, it is greater than. So it is more than, that is here the correct answer is C, that is more than. The thermal efficiency of diesel cycle having fixed compression ratio with increase in the cutoff ratio will be, and the options here given are A, increase, decrease, C, be independent, D, may increase or decrease depending on other factors. So here, in order to understand this, we should understand what is cutoff ratio. Cutoff ratio here is V3 upon V2. So V3 upon V2 is the cutoff ratio, and we are talking of the thermal efficiency, relation between the thermal efficiency and cutoff ratio. So the thermal efficiency of a diesel engine having fixed compression ratio, we are keeping the compression ratio fixed, that is 1 to 2, we are keeping it fixed. With increase in the cutoff ratio, that is 2 to 3 is being increased. So here you can see cutoff ratio is 1, here cutoff ratio is 2, here the cutoff ratio is 3, and for different compression ratios we are talking of. So if you can see over here at a particular compression ratio, when the cutoff ratio increases, the thermal efficiency, the cutoff ratio increases. So here it is 1, this is 2, 1, this is 3. That is, as the cutoff ratio increases, the thermal efficiency of the engine seem to be decreasing. So the correct answer will be B, decreasing. The advantage of air injection system is, so here we are talking of the air injection system. So this was the earlier type of diesel injection system where compressed air was supposed to be used for injecting the fuel into the. So here you can see the it is similar to that of a spray gun or guns which we use for painting. So on one side a compressed air will come. Here this particular fuel will be injected, that is the air will be injected on the fuel molecules, and that will make this particular fuel to form droplets and disperse in out of the gun. So this is the way we create the atomization. So we are talking of here the specifications of such a method, that is cheaper fuel can be used. So here you can see with this particular method, any fuel, it is immaterial until we have sufficient energy in the compressed air to break this particular fuel into smaller droplets. So cheaper fuel can be used. Mean effective pressure is higher, so it is again because we are using air, so it is compressed air to atomize the fuel, and when we know that when we are able to atomize the fuel properly, we are able to burn it properly, and correspondingly the mean effective pressure is going to be higher. Fine atomization distribution of the fuel, so here increase in the pressure of compressed air is able to have more proper atomization and distribution of the fuel. So the cheaper fuel can be used, mean effective pressure can be higher, and higher amount of atomization and distribution is possible. So the correct answer is D, all of the above. Advantage of fuel injection in system is obviously cheaper fuel can be used. All these are the advantages of fuel injection system. That is, cheaper fuel can be used, mean effective pressure can be higher, fine atomization and distribution is possible. So all of the above is the advantage of any fuel injection system. Thanks a lot.